We are going to briefly chat about multiplying radicals. What's so nice about them? To multiply radicals, there's really only two steps, I guess. So to multiply radicals, you don't need them to be like radicals. They can be anything they want. So you're just going to multiply all numbers in the radical together. And then step 2 is just simplify your answer. That's it. Miss Savia, it can't be that easy. Oh, but it is. So if I had something like the square root of 5 times the square root of 3, literally all I do, since they are both under a radical, I just multiply them together and I get the square root of 15. And then I ask myself, can I simplify the square root of 15? Are there any perfect squares that divide into 15? No, so I'm done. Wow. It's that easy? Well, basically, if I did something like the square root of 6 times the square root of 3, what does that get me? Square root of 18, but is that a final answer? No, that one can be simplified 9 and 2, so it really becomes 3 root 2. But that's pretty much it. Oh, wait, Miss Savvy, what if there's numbers out in front? What if you had something like 2 root 3 times 4 root 5? What are you supposed to do with that? Well, it's almost the same idea. And this is all multiplication, right? It's all, even though I don't have a dot in between that 2 and the root 3, it's all multiplication. It's the same thing as writing it separately. 2 times root 3 times 4 times root 5. Same thing. It's all multiplication. So all you're going to do is multiply the numbers that are not under the radical, and then multiply the numbers that are under the radical. That's it. So this answer is just 8 root 15. I know. The only way it gets harder is if you have to simplify an answer. So let me give you a harder one. And let's throw some negatives in there. How about negative 6 root 5 times, I don't know, 3 root 10. Okay, everybody try that one. Multiply that together. Okay, got an answer? When I do my first step and I just multiply, all right, well, a negative 6 times 3, that's a negative 18, and then in the radical I have 5 times 10, that's 50. So did you get that at some point, negative 18 root 50? Good. And then you said to yourself, okay, is that a final answer or can that be simplified? That can be simplified. The largest perfect square that goes into 50 is 25. So hopefully you've split that into 25 and 2. So it's really negative 18 times 5 times root 2. So negative 18 times 5 is what? Negative 90? Is that right? So my final answer, negative 90 root 2. Did you get it? Or do you see how I got it? Does that make sense? Yes. All right, so you might see some other interesting things like what would you do with this thing? Distribute, right? So what's root 2 times root 3? Root 6. And then what's root 2 times 4 root 5? 4 root 10. Can I simplify that answer? Root 6 plus 4 root 10. This doesn't have any perfect square factors, and they're not like radicals, so I can't add them together. Let's try one more where you have to distribute. How about you guys do this one? How about 3 root 3 times root 6 minus root, I don't know, 11. Try that one up there. Okay, we got something? What's 3 root 3 times root 6? 3 root 18 is correct. I'll come back and I'll fix that later. Let's do 3 root 3 times negative root 11 would get me negative 3 root 33, right? Okay, so everybody got this at some point? Now I say, oh, okay, 18, that can split into 9 and 2. So, square root 9, square root 2, bring down the 3. So it's really 3 times the square root of 2, or 9 root 2 for that first thing. Can I simplify the square root of 33? No. I know you're thinking, doesn't it split into 3 and 11? Yes, but 3 and 11 are not perfect squares, so it doesn't help you any. You have to be looking for a perfect square that goes in. If it's not a perfect square, I can't do it. So I just bring down the minus 3 root 33, and that is my answer. Let's try a binomial times a binomial. Oh, yeah. Try that for me. What do you do with this thing? Oh, yes. Binomial times a binomial. We need to FOIL. Good. What do you mean you got an email from Google Classroom?
Yeah, but it was from like March, and I just didn't open it.
Oh.
Yeah, I was looking at my like emails from like.
Oh.
It just said like test released, and I thought it was like this test.
Oh, gotcha.
First, I have last. See the individual square root of 2 times 1 would be negative 1 square root of 2.
Okay, let's try it. First, when I multiply square root of 2 times square root of 2, what does that get me? Square root of 4, which is just 2. Guys, how do you undo square rooting something? You square it. So when you have the exact same radical and you multiply them together, the radical just goes away. So square root of 2 times square root of 2 is just 2. I mean, you could do it out the long way, right? Square root of 4, and the square root of 4 is 2. But anyway, there's my first. Outers would be minus root 2. Inners would get me a positive 5 root 2. And then the last would get me a minus 5. All right. Do I have any like terms here? Or like radicals, I mean. Yes, you have 2 of them. You have this, the root 2's will go together, and so will the 2 and the negative 5. So 2 and negative 5 get me negative 3. And then negative root 2 plus 5 root 2 gets me, close, positive 4 root 2, yep. And that is my final answer. And in this case, you should have it written in that order. If you have the minus 3 on the end, just move it to the front. So you always want to get in the habit of having your square root as the very end of your answer if possible. So what do you think? Is it so bad? It's not so bad, right? Right? Okay. So I'm going to let you get